Topic for the day is transformation. When do we use transformation? When we have skewed data and we need to convert into a normal distribution data. If we have a skewed distribution data and we need to convert it into a normal distribution data, we use transformation. Why is skewness wrong for our data? Basically, skewness affects my model accuracy. Two types of skewness are left skew and right skew. What is your left skew? Basically, your left skew is whenever your data has left tail in distribution, it is called as left skew. What is your right skew? Whenever your data has a long tail towards right side, it is called as right skewed or positive skewness. Left skew is also called as negative skewness. Right skew is also called as positive skewness. To visualize skewness, we have three things: box plot, QQ plot, histogram. Let's see what box plot is. Basically, your box plot looks like this. It has whiskers and median. If distance between median and your right whisker is much farther, then it is your right skewed or positive skewed. If difference between your median and left whisker is much longer, then it is called as negatively skewed or left skew. As simple as that. QQ plot. It is plot between your sample quantile versus theoretical quantile. The red line is basically your line for a normal distribution. If your data has a curve above the red line, it is called as positively skew or right skew. If your data has curve below the red line, it is called as negatively skew or left skew. As simple as that. What is histogram? Basically a data distribution where y-axis is your frequency, x-axis is your data point. Various types of transformations are, let's see, we have log transformation, reciprocal transformation, square root transformation, exponential transformation, Box-Cox transformation, and Johansson transformation. When do you use log transformation? Whenever my data is right skewed, I'll be using log transformation or reciprocal transformation. Whenever my data is left skewed, I'll be using exponential transformation. Square root transformation, Box-Cox transformation, and Johansson transformation can be used in all the cases. Formula for your Box-Cox is this. Formula for your Johansson is this. Another important thing, in your reciprocal transformation, you can't have data having zero values. And in your Box-Cox, only data which can be fit using Box-Cox transformation is data which has greater than zero values. Data having zero and negative values are not allowed in your Box-Cox. Let's see your Python implementation. This is my data. I'll find out distribution using histogram or distribution plot, which is frequency on y-axis and my data on x-axis. I can clearly see the tail is towards right side, so it is right skewed. Right skewed. Next, a quantile plot for sales data, theoretical versus here sample quantile. The red line is basically your normal distribution, and if your curve is above the red line, it is called as positively skewed or right skewed. Same thing we can see in our histogram, right skewed or positively skewed. Moving on, because my weekly sales is right skewed data, I can apply log transformation or reciprocal transformation. After applying a log transformation, the data which was earlier right skewed is now pretty much towards a normal distribution. It is not a perfect normal distribution, but it is pretty much towards normal distribution. Left skewness has reduced. The QQ plot now looks like this. QQ plot for logarithmic transformation looks like this. Earlier, the blue curve was only above your red line. This is my temperature histogram. We can clearly see it is left skewed. QQ plot also tells me, because the curve is below the red line, it is left skewed or negatively skewed. After applying a square transformation, because my data is negatively skewed, I will try to apply square transformation or any exponential transformation for that matter. It will give me a data with reduced left skewness. If you see, the tailness of left skew has reduced. This is what QQ plots looks like now. The curve which had a greater area under the red line has now reduced. Applying Box-Cox, you can use stats.boxcox. and it has also reduced your left skewness and right skewness for your cells. Your cells was basically right skewed. It has reduced it. This is Yo Johnson. Yo Johnson. You can use it from sklearn.preprocessing. It has a power transformer. The method you can give is Yo Johnson. You can see the result. The QQ plot for your sales after having Yo Johnson is like this. Earlier, it was above your red line. Now it is pretty much aligned to your red line. Thank you. This is all for the video.